5.3, solving equations with and without logs, not tree logs, logarithms, okay? How we do this? Use the properties of exponents to simplify each side of the equation. Rewrite the equation so that's the same, rewrite the equation so both sides have the same base, and then drop the bases and set the exponents equal to each other. Sounds more complicated than what it actually is. If we go to this first one, okay, so looking at these two sides of my equation, okay, do we notice how both sides of this equation have the exact same base? Yeah. Do we all see that? Cotter and TJ, get with me. Do we all see that both sides of this equation have the same base? What is the base?
2.
2. Okay, so that matches. So basically what I can do, since I have the same base, is I can just set their exponents equal to each other and solve that. That's a really easy equation to solve, wouldn't you agree?
Yeah.
If you can't solve that, that's not good. What does x equal? 8. Cool. Okay, you try number 2. Try number 2. Okay, number 2, what'd you do?
4n plus 5.
Yep, they both have the same base, so you are totally allowed to do that. 4n plus 5 equals n minus 7. How'd you solve it?
I subtracted n over to the left.
Good, I like to subtract the smaller variable too. So we get 3n. Did you subtract the 5 over to the other side?
Yeah.
So 3n equaled negative 12. And then what?
N equals negative 4.
Divide by the 3 and n equals negative 4. Good. Questions on that? Cool. All right, so moving on. Number 3. Do we see how we now have 3 different exponents here, okay? But they all have the same base, okay? So we can't do what we just did until we have one base on each side and they match, okay? So looking at the left side, we need to do some condensing there, don't we? TJ, what would you do?
Would you combine like k plus 2?
You're right. Yep, you would add the exponents. So anytime you're multiplying two things with the same base, you just add their exponents. So this would be the same thing as 3 to the k plus 2 power equals 3 to the 5k minus 1. What is k plus 2?
2k plus 2.
2k plus 2. Okay, now is this something I can solve like what I just did previously? One base on each side and they match? Yeah, so we'll just take our exponents, 2k plus 2, set it equal to 5k minus 1. Good deal. Then tell me what k equals. K equals 1. Okay, so we subtract 2k over. Add 1 over. I would agree. K is going to equal 1. Good deal. Questions on that? Are we feeling pretty confident about this? Do number 4 quickly. Okay, number 4, what did you do? Combine negative 4 and 9 on the left, so you got 10 to the 5th. Okay, what about the right?
3 plus 4 plus 2 minus 1.
Good, so add all those exponents together and you get 10 to the 3b minus 7. Good. Now what? So 5 equals 3b minus 7. Add the 7. 12 equals 3v. What does v equal? Raise your hand if you got that one. Good. We got a bunch of smart cookies in here. I like it. Yeah, we do. Okay, here we go. Equations without a common base. So unfortunately, it's not always going to be that simple, okay? So sometimes they're going to give us equations that look like this, okay? And we have to make our own common base, okay? But we've been doing this before, okay? We know what exponents are, right? So here's the strategy I want you to use for this. If you see an equation like this and both sides do not have a common base, I want you to first just look at the two bases that you have. So in this case, we have 6 and 36. Which one's smaller? 6, okay? So what I want you to do is I want you to start with 6 and figure out what the powers of 6 are. So 6 to the first is 6. 6 squared is, ooh, do we have both numbers? That works. So here's what I'm going to do. The left side, I'm going to keep it the same because it's already a base of 6. The right side, I'm going to change that to be 6 squared. See what I did there? Yeah, what can I do now? 2x minus 10 equals 2. And solve it. What did you say x equals? 6. Good. Add the 10 over. 2x is 12. So x is 6. Perfection. Pretty sweet. Questions on that? Okay. I want you to do number 6 then. Look at the two bases. Which one's smaller? Write the powers out. See if you can get this to work out. Okay, so what's smaller, 2 or 8? 2. Okay, did you write the powers of 2 out here? So 2 to the first is 2. What about 2 squared? 2 to the third? Ooh, do we see it? Yep, so how'd you set this up? Perfect. Now what? And what's P going to be? 10. Pretty good, pretty good. Okay. Everybody get that one? Yeah? Cool. Number 7. We'll look at this one now. Okay. So when you see two bases, okay, and we're looking to find which one is smaller of the two. Well, if I look at 7 and 1/7, obviously the fraction is going to be smaller, right? 1/7 is smaller than 7, okay? But when we deal with fractions, I want you to not look at the fraction itself, but just look at its denominator, okay? So if I look at my two bases, then would be 7 and 7. Which one's smaller? Well, obviously they're the same number, right? So 7 to the first power is 7, okay? And I don't need to go any further. So now I look, okay? My base is 7. So that one's going to stay the same. But then 1/7, well, if we remember the rule about fractions, we just make our exponent a negative. So this is the same thing as 7 to the negative first power. So you might want to write that rule out to the side if you need it. Okay, so anytime you're dealing with a fraction, make the exponent negative. Okay, so now how do we set this up? Perfection. Subtract 11 over, right? 4x is negative 12, and what's x going to be? Negative 3. Any questions on that? Okay, cool. Skipping number 8, going to number 9. All right, so we look, which is the smaller of the two? 3. Okay, so we'll go over here. 3 to the first is 3. 3 squared. 3 to the third. Perfect. So we got both of our bases, okay? But pause real quick. Do we see how our exponents aren't just one variable or one letter? Or sorry, not letter, one number, okay? So when we have something like this, okay, and we've got to break 27, we just said 27 is the same thing as 3 to the third, right? So what I'm going to do is just put 3 to the third in for 27, but I still have to keep the same exponent that is there. Okay. And now I want you to pause real quick. Pause on this problem. Let's say, for instance, that I had this. I meant to do a warm-up today, but I forgot to put it up here. If I had x to the 4th raised to the 6th power, what would those exponents do to simplify? Multiply, okay? So up here we added, right? If we were multiplying, we added their exponents. But if we are raising to a power, we actually are going to multiply. So this would be the same thing as x to the 24th. So maybe just like put a star and write that over there. The power property, power rule. Okay, make sure we're good on that. Power rule of exponents. But same thing is going to happen here, okay? So I'm just multiplying these two values, 3 times 2x plus 6, okay? So this is going to be the same thing as, and actually I have to distribute out that 3, right, since we're multiplying it. So this is going to be the same thing as 3 to the 6x plus 18 equals 3 to the 2x. Does everybody see how I did that? We just multiplied the values together. So we distributed that 3 to both of those exponents, okay? Or to both of the terms in that exponent. Okay, so now we're ready to set this up. 6x plus 18 equals 2x is what Tate said. Now what'd you do to solve this? Subtract 6x. So 18 equals negative 4x. And now divide by negative 4. And what is 18 divided by negative 4? You can give me a decimal if you need to. Ooh, I heard a lot of things. What? Negative 4.5. Good. Good, good, good. Questions on that? Okay. Good deal. So I want you to try number 10. Good deal. A lot of us got that one or else we were super close. So 4 and 16, we knew that 4 was smaller, so we wrote the powers of 4 out. 4 squared is 16, okay? So we leave this one alone on the left. This becomes 4 squared to the y minus 3. Then we must do what with that 2? Distribute it, right? So this is the same thing as 4 to the y plus 2 equals 4 to the 2y minus 6. Y plus 2 equals 2y minus 6. Subtract y over, add 6 over, and y equals 8. Figure 8. Good deal. Questions on that? We feel okay about that? Are we ready to move on from there?
Yeah.
Cool. Okay. Number 11. So we look. Our two bases are what? 125 and 25. Which one's smaller? 25. So we start with 25. Take it to the first power. It's 25. Good. What about 25 squared? It's more than 125, right? It's going to be a big number, okay? So would you think that this is going to work as our common base? Probably not, okay? So instead, what we've got to do is we've got to come up with a smaller number that can be a common base for both of them. So if I think, if I see 25, I should automatically think 5. So we'll try that. We'll start to write out the powers of 5. 5 to the first is 5, 5 squared is 25, and 5 to the third is 125. So we got them both, don't we? Okay, so how we would set this up is we're going to do the same thing, except for we have to do it on both sides. So 125 is 5 to the third, and again, it's still to that y power, so don't forget about its original exponent, equals 5 squared. So now we multiply those two values, or the exponents together, so 5 to the 3y equals 5 squared. Same base now. I'm good to set up my equation. Y is going to equal 2/3. How do we feel about that? Decent? Okay, I want you to do number 12. It's going to work similar. Try number 12. Okay, what do we do? Try to find a common base. And it's 2. It's not going to be 8. Why can't 8 work?
8 squared is 64.
8 squared, 64. Good. Okay, so we use 2. 2 to the first is 2. 2 squared is? 2 to the third is? 2 to the fourth is? Cool. So the left side becomes what?
2 to the 4th times
times 3x, and the right side, 2 to the third times x plus 2. Okay, so on the left it becomes,
2 to the 12x.
mhm,
2 to 3x plus 6.
okay,
And then you set them equal to each other.
set the exponents equal to each other,
Subtract 3 over.
subtract 3x over,
9x equals 6.
9x equals 6,
X equals 6 ninths, and that equals 2/3.
x is 6/9, which is 2/3, Carter. Gotta simplify. Duh. You can do a decimal, you'd get 0.6 repeating. So if you put 0.6 repeating, you're good too. Good. Okay. How do we feel about that? How many of us got that? Or almost got that at least? Almost got it? Okay. Okay, we're going to move on to number 14. Numero 14. Okay. Listen. Okay. So we're looking at these two bases, correct?
Yep.
So I'm looking at 81 and
3.
3, because I look at the denominator of a fraction, which is smaller, 3. So we'll try this one. 3 to the first is 3. 3 squared is 3 to the third is, what's 3 to the fourth? 81. Okay, I want you to try this one. Finish it off. Okay, what'd you do? On the left, what did that become? 3 to the fourth times 2x plus 5 equals what?
3 to the -2x. Is that right?
Yep, 3 to the negative first times 2x, which is the same thing as 3 to the negative 2x. Good. And on the left side, this becomes 3 to the 8x plus 4 times 5? 20. Okay, you're okay. How many of us made it that far at least? Yeah? Okay. If we didn't, hopefully we see what we did. So now what? Yep, set it equal to each other. And subtract the 8x over. So 20 equals negative 10x, and what does x equal to 8? Good. Good. Okay. Last one we're going to do, and this one, well, last one for this page, and then we're going to move on to the next thing. Number 18. This one's kind of a challenge one. This is kind of throwing together a couple different concepts, so give this one a go. So on the left side, we're multiplying two of the same base together, which means to do what with the exponents? Add them. So that's the same thing as 9 to the 4x plus 4. Good. Equals 1 over 81. Now we look at our two bases. 9 and 81, which one's smaller? 9, so we'll see if that works. 9 to the first is 9. 9 squared is 81. Cool. We're golden. So this is the same thing as 9 to the 4x plus 4 equals 9 to the negative 2. Why is it a negative 2? Because it's a fraction. Good. Lastly, 4x plus 4 equals negative 2. Subtract over the 4. 4x equals negative 6. And what does x equal? Negative.
3 over 2 or negative 1.5.
Good. Negative 3 over 2 or negative 1.5. I like it. Questions on that? There will be one like that on your quiz, which is not next class, but the class after that.
Why didn't we have a Tuesday?
Okay. Almost done for the day, but we got a little bit more to do. Okay? What if a common base is not possible? So for instance, looking at this, I look at my two bases, which are 2 and 61. If I start writing out my powers of 2, am I ever going to make 2 equal 61?
No.
No, I cannot. Okay? So, if this happens, your first thing you got to do, isolate the exponential expression. Okay? So get them both isolated, or get the exponent isolated. Okay? take the log of both sides, and then sometimes we also have to expand these, but I'll show you what I mean once we get solving these. So we'll start with this one, okay? This one is already isolated. The exponent's on a side by itself with the base that it has, okay? So what we're gonna do is we're going to change this to logarithmic form. So it's log, it's got a base of 2 of 61 equals that exponent. This is what we did last time, okay? So we've seen this before. And now we just solve this in our calculator, which we have also seen before. This is that rule, okay? You might want to write it down. Log of A divided by log of B. In our calculator, it's just base 10, which we don't have to write. So log of 61 divided by log of 2. And make sure when you type these in, you close the parentheses on that first one, or else it's going to count it wrong or give you the wrong answer. So type that in, log 61, close parenthesis, divided by log of 2. And round it to 3 decimal places if it is necessary. 5.931. Did everybody get 5.931? Anybody not get 5.931? Everybody? Okay, cool. That's how these work. So same thing's gonna happen over here. My base and exponent are isolated, so I'm good to start solving. Log of base, what's my base here? 8 of 92 equals the exponent, m minus 7, okay? Calculator on the left side, log 92 divided by log 8 equals m minus 7. Round it to 3. 2.175 equals m minus 7. There's one more thing we got to do. Is m by itself? Nope. What should I do? Add the 7 over. You got it, Tate. 9.715 equals m. And we're done. Questions on that? Okay. All right. 5 and 6. Before we start these, okay, I want to just look at, for instance, a basic equation that we're solving. And we've been solving these all day, and you guys have been doing pretty good with it. So, for instance, if I had 7x plus 2 equals 9. How would I solve that first? What's the first thing I would do? Subtract the 2. Okay, so I'd get 7x equals 7, and the last thing I would do, divide by 7, okay, and I'd get x equals 1. Same thing as if this was just 7x equals, I guess, 9. The first thing I would do then would be to divide, right, because I don't have anything to add or subtract over. Okay, so these are going to work the exact same way. So if I look here at number 5, pretend for right now that this is just a variable, that whole base and the exponent, okay? So the first thing I would do to solve this, if this was 4x equals 148, would be to do what? Divide the 4. I've got to divide that 4 first here. Yeah, we do. So 7 to the n equals, what's 148 divided by 4? Yeah, it's going to be a number. 37. Cool. Okay. Now we're good to go. Now we can start solving this. Okay, so we would check 7 and 37. Not going to be a common base for those, unfortunately. So we have to do the calculator way. So go ahead and set that up for me. Okay, how'd you set this up? Perfect. Raise your hand if you agree with that. Log base 7 of 37 is n. Yeah? Okay, cool. That's right. And then the last thing, I've got to find my answer. So what would I type into my calculator? Yep, log A divided by log B. So log 37 divided by log 7 is going to equal n. And n is going to be what decimal? 1.856. Cool. Any questions on that? We feel okay about this stuff? It's not too bad. Okay, 6 is going to be very similar. But instead of dividing something over, what do you got to do first? Yeah, maybe add something over, so try that one. What's the first thing that we do on this one? Yep, we said add the 5 over, just like if we were solving an equation. So this is 4 to the 3w equals 8. Okay. If we saw it on this one, they do have a common base, okay? But let's say we didn't see it, okay? And we just went along because we can use a calculator on the whole test and the quiz, all the rest of the quizzes, right?
Yeah.
So we could just go ahead and do the calculator way, which would be log what? Log base 4 of 8 equals 3w. So what we type in our calculator would be what? Yep, log 8 divided by log 4 equals 3w. What does that equal? 1.5 equals 3w. And last but not least, divide by the 3. What is 1.5 divided by 3? 2. Okay. How are we feeling?
Why couldn't you do the 2 squared? 2 to the third?
We're almost. Okay. I want to look at number 7. We'll do this one quickly together. Okay. So this one, what this kind of reminds me of, I guess, is like 7 minus x equals 18. So if I were to solve that, what would be the first thing I'd do? You don't have to write this down. You would, if you had this equation. Minus the 7, good. So you'd have negative x equals 11. Then what would you have to do? Divide by the negative, right? Okay, so this one might work kind of similar to that. Let's see. If I look, what should I do first? Subtract the 7. Do we all see that? So negative 4 to the x plus 1 equals 11. But can I have that negative out front? No, that's important. Divide it over. So 4 to the x plus 1 equals negative 11. Are 4 and negative 11, could they have a common base? No, probably not. So we'll set this one up. Log base, what? 4 of negative 11 equals... Ooh, we saw this on our quiz. Can we do this?
Oh.
Try typing that in your calculator. Type log of negative 11 divided by log 4 and see what it tells you. Yeah, on the quiz we wrote undefined, right? Your calculator is going to say domain error. Cool. So what do we think we should write? You could write undefined. You could just write no solution. Does anybody remember that little like symbol that means no solution? Yeah, I kind of like that thing. It's kind of fun. Pretty cool. Okay. We're done with regular logs. We got to do a couple natural logs, but that's okay. Because remember, natural logs are healthier for you than regular logs. There's no difference for you? You don't know the difference? It's okay. It's just the base. Natural logs have a base of E, and regular logs have different bases, okay? So if we look, these are going to work the exact same way. Just pretend that this thing isn't a variable. So you get it isolated, okay? And then solve. So we'll look at this. First thing I need to do is do what? Subtract the 2. So we get 2 to the EX equals 88. Now what? Is it isolated or do I need to divide by 2? Cool. So e to the x equals 44. And now these actually, in my opinion, are easier than logarithms, because the way I type this in my calculator is I literally just type natural log of 44 and set that equal to the exponent. And again, make sure you use the natural log button. Don't use log. Make sure you use the ln button. What is ln of 44? 3 point what? 784. Yep, let's do 3 decimal places. Good. Then we're done. Okay. Let's do one more. Do you want to do 11 or 12? 12? Okay.
Yeah.
Do you guys want to try it first?
No.
No. Actually, that one's not a natural base one. We don't have to do 11 and 12. Let's do 10. Try that one. Okay, we look. Is the base with the exponent, is it isolated?
Yes.
Is there anything with that e? No, there's not. It is isolated. Good deal. So now we just take the natural log of what? ln of 87 equals 3x minus 5 equal to the exponent. Good, good, good. What is the ln of 87, or the natural log of 87? 4.466. Okay. Equals 3x minus 5. Now what? Add the 5. Good. So 9.466 equals 3x. Now what? Divide by 3. And what does x equal? 3.155. Anybody get that one?
Yeah.
Cool. All right. Awesome. Any questions on today? We feel all right? Confident?
Yeah.
Yeah.
10 out of 10?
Yeah.
Yeah? Cool.